welcome to Mrs. Miller's notes for her double block algebra class. These are the notes for section 4.7 entitled Graphing Lines Using Slope-Intercept Form. And today we're going to solve equations for y so that we can identify their slope and their y-intercept. And then we're going to graph those equations using the slope-intercept form. And the slope-intercept form is probably one you're familiar with. It's y equals mx plus b. And the y and the x in the equation are going to stay y and x, but the m represents the slope, so that is your rise over your run, and then the b, that represents your y-intercept. So that'll be the number on the y-axis where your graph is going to cross the y-axis. So it'll be 0 and then whatever number is in that b spot. Could be positive number or a negative number. Could be fraction, whole number, decimal. The slope could be a whole number or a fraction. We're going to preferably write it as a fraction. And remember, every whole number you can put over 1 to make it a fraction. Okay, so let's take a look at some problems where we're just finding the slope and the y-intercept. Now, part A is pretty easy for this one. All we have to do is look at it to find the slope and the intercept because it's already solved for y and it's already in slope-intercept form. It has the x term first and then the number. This is why, as we've been solving equations for y and putting them in function form, I've been telling you to put that x term first and then the number because now it's in slope-intercept form. And all I have to do is look at this number in front of the x, look at this number at the end, and I can tell you that my slope is 4, not 4x, just 4. It's the number in front of the x. A lot of times students put 4x for the slope, and it's not the x, it's just the number in front of it. And you could even think of it as 4 over 1. And then my y-intercept is going to be the ordered pair 0, and then the number that's in that b spot, which is the -5. Don't forget the sign in front of the number. If it's a -5, you need to take that minus with as a negative with the 5. Now part B is a little bit different because it's not solved for y, so we have to do that first. We have to put it in function form. So I have to subtract the 8x. So then I'll have 2y equals, and again I'm going to put that 8x first, and then the 14. And then I have to divide every single number by 2. So I'll have y equals -4x plus 7. Now that it's in slope-intercept form, I can look at the number that's in front of the x and the number that's added on at the end, and those are my slope and my intercept. So my slope is going to be -4 or -4 over 1, and my y-intercept is going to be 0 and then 7. And it really is that easy. For part C, we're going to do the same thing. We have to solve for y first. This one looks a little trickier just because there's not a number in front of the x. You could put a number in front of the x though. Remember, if there's no number there, it's going to be a 1. So we'll have 2y equals -x plus 4. And then I'm going to divide by 2. Again, this is a good time to think that there's a 1 in front of this x. It's a -1x, especially now because I'm going to have y equals -1/2 x plus 2 as my equation. I want to leave that fraction as a fraction because that fraction now is my slope. It's telling me how much I'm rising and running. And then my y-intercept is going to be the number that's added on at the end. That's the 0, 2. In part D, I'm going to, again, solve for y. So I have to subtract the 3x over. I'm going to keep the -2 with the y. And then I'm going to write the -3x first, then the +6, divide everything by the -2. So y will equal, now here I have -3 over -2, so I'm just going to leave that 3 over 2. Negative divided by negative is a positive. 3 over 2, I'm not going to write it 1.5 or 1.5. I'm just going to leave it 3 over 2. It's already reduced as much as it will be able to reduce. And then 6 divided by -2, that's going to be -3 or -3. So for this problem, my slope is going to be the 3 over 2. So I'm rising 3 and I'm running 2. And then the y-intercept for this problem is going to be 0, -3. Now part E looks a little tricky. It's not meant to be tricky. It's meant to be nice. It's already solved for y. Y is already by itself. Y equals x. And it might look like there's some stuff missing. So let's rewrite it just a little bit with the 1 in front of the x. And then there's a plus 0 added on at the end if we want to add that in as well. So having it written like this, where every single term or every single spot is filled in, that seems a little less intimidating than the y equals x. So sometimes when you see very simple equations like this, it looks like there's something missing. That's just because they're not including the 1 or the 0, the 1 in front of the x or the plus the 0 that's being added on for the intercept. So here my slope is going to be 1, or 1 over 1, and my y-intercept is going to be 0, 0. And this is actually a special type of a line. This is the identity function. And when you graph it, you always get a diagonal line that goes up from left to right, and it goes through 0, 0. So this is actually a very special, very useful line in mathematics. Okay, so now for example 2, we're going to do the same thing that we were doing. We're going to find the slope and the y-intercept, and I'm going to show you how you can just use those two pieces of information to graph the equation. You don't need to make a table anymore. If you can get an equation into slope-intercept form, you do not need to make a table to graph it. I'm going to show you that shortcut. So for part A, I have y equals 1/2 x minus 3. The y is already solved for, so I'm going to write down that my slope is the 1/2. Remember, not the 1/2 x, just the 1/2. And my y-intercept is going to be 0, -3. So I'm going to plot that point first on my y-axis. So I go to 0, -3. And then my slope is 1/2. So I'm rising 1 and I'm going over 2. Now, the number in the numerator of your slope always tells you how much to go up or down, and the number on the bottom always tells you how much to go to the right. We're not typically going to go to the left on the graph unless we're backtracking. Okay, so you want to remember that the numerator tells you to go up or down, the bottom number tells you to go to the right, always to the right. So in this case, my numerator is a positive 1, so I'm going to go up 1 from the point that I just plotted, and then I'm going to go to the right 2, and I'm going to put a little spot, or a little point. Then I'm going to do it again. I'm going to go up 1 and over 2. Up 1 and over 2. And I can keep going as many times as I'd like. Well, I'm going to stop there because I'm going to go off the graph. Now I could backtrack. I could go to the original point that I plotted, the 0, -3, and instead of going up 1 and over 2, I could go down 1 and back 2. So this is the only time that we go to the left on the graph, is when we're going to run off the graph or if we need to plot some extra points. Now really when you're making this graph, you just need 3 points. But since it's the very first time that we're plotting this way, I wanted to do it several times so you could see it repeated. So for part B, we have y equals -3/4 x. And again, it looks like there's something missing in this equation. So think of the little plus 0 being added on at the end for our intercept. Now before I even start graphing, I'm going to write down my slope. My slope is -3/4. And then I'm also going to write down my intercept, which is going to be 0, 0. So that's meant to be nice. When there's nothing added on at the end, that's meant to be nice. But sometimes students get a little stuck on that just because there is no number there and they're not sure what to do. So now from 0, 0, I'm going to move according to my slope. I'm going to rise and then run. But in this case, I'm not really rising because the 3 is negative. So I'm going to be going down. I'm going to be falling. But I'm still going to go to the right. So I'm going to go down 3 and then to the right 4 and put a point. Down 3 more and to the right 4. Okay, and that's enough points to make your line. But if you want to make some more points going the other direction, you can, but now you have to reverse your movements. So go back to 0, 0 and go up 3 and to the left 4. Again, this is the only time that we go to the left is when we're backtracking. And there's your line. Now my graph in part A had a positive slope, so you can see that from left to right, my line is going up. It's kind of like if you were in a little car and you were driving uphill, that's got a positive slope. And in part B, my slope was negative 3/4, so that means my line should be going down. So from left to right, as I look at this graph, I am going down. Just like if we were in a little car, we'd be going downhill. If we were on a roller coaster, we'd be going down there. And then for part C and D, these are a little bit more intense just because they're not already solved for y. So I'm going to have to solve them for y first. So for part C, I'm going to have to subtract that 4x over to the other side. So then I'll have y equals negative 4x plus 5. So my slope will be the negative 4 over 1, and then my intercept will be 0, 5. So I'm going to plot that point first, and then from there I'm going to go down 4, since my numerator is negative, and over 1. This is why we want to put every whole number over 1. Sometimes students forget to do that, and then they just have points that go down 4 and they put a point, and down 4 and put a point, and down 4 and put a point. So then they have a vertical line. That's not what we're graphing here. Our line has a slope, so we need to go down 4 and over 1 unit. Now, if we had a real world scenario for this, this might be that you lose $4 for every one hour of TV that you watch or something like that. It could be like a punishment. Or every hour that goes by, 4 gallons of water drain out of a big tank. Okay? So that 1 represents something. It represents 1 increment of time or TV. Okay? Something like that. And then in part D, wow, this equation looks really intense. We still have to get the y by itself, though. So there's a couple different ways we could approach this. I like to leave the y where it is and get rid of everything else. And to get rid of this 4x, I'm going to have to subtract it over to the other side. And to get rid of this minus 15, I'm going to have to add it over to the other side. So we can do that in 2 steps, or we can do that in 1 step. I'm kind of writing it in 1 step since I'm a little short on room here, but I'll finish writing it down below. So I'm going to have 5y all by itself then, and I'll have the negative 4x and the plus 15 that move over to the other side of the equation. So I have 0 plus 15. So even though they're like terms, when I combine them, I just get the 15. And then I have the minus 4x. Now I still need to divide by 5. So everything's going to get divided by 5. So y will equal, remember, negative divided by negative is going to be a positive 4/5 x plus 3. So my slope for this equation is going to be 4/5, and my intercept is going to be 0, 3. Oops, wait a second. Why did I make the 5 negative? We don't want the 5 to be negative. We want the 5 to be positive. So my slope here then will be a negative 4/5. There we go. I was adding a negative with the 5 when I was dividing. That's not right. Okay, now it's correct. So now we have a negative 4/5 x plus 3. So our slope is negative 4/5. My intercept is 3. So I'm going to start at 0, 3. Remember, we always start on the y-axis because it's a y-intercept. Sometimes students like to start on the x-axis. We're starting on the y-axis. Just think, where is that point if I plot it? And then from there, I'm going to go down 4 and to the right 5. We always go to the right. So down 4 and over 5. Down 4 and over 5. 1, 2, 3, 4, over 5. There we go. Now again, I could backtrack if I wanted to, but I've got 3 points, so that's enough to make my line. But if I wanted to backtrack, that's when I would go up 4 and to the left 5. So that's the only time we go to the left. Always for rise over run, we're always running to the right. There we go. So again, my slope was negative, so this line's going down from left to right. Same thing with part C. My slope was a negative 4, so I'm going down from left to right. Okay, now the last concept that we have is about parallel lines. And you're just going to see a few problems like this in your homework. And you should be familiar with the concept of parallel lines. They're different lines that are in the same plane, the same coordinate plane, they're on the same graphing grid. However, parallel lines have 2 characteristics that make them parallel. Usually students say that lines are parallel because they never touch. Well, that's true. Parallel lines never touch, they never intersect. But the reason they do that is because they have the same slope. That's the only way you can get lines that are in the same plane to never intersect. So if one line has a slope of 1/2, a line that's parallel to it also has to have a slope of 1/2. They can have different intercepts, but they have to have the same slope. So for example 3, our last one here, we're going to figure out if these lines are parallel. So here's my first line, 3y equals negative 9x minus 5, and here's my second line, 12x plus 4y equals 1. So the fastest way to do this is to solve both of them for y, and then look at their slopes. Get them into slope-intercept form, and then you can compare the slopes and see if they're the same or different. If they're the same, they'll be parallel. Okay, so my first line was the 3y equals negative 9x minus 5. The only thing I have to do to solve this equation for y is to divide everything by 3. So y equals negative 3x minus 5/3. Now here I have a fraction for my intercept. That's okay. We haven't seen that yet, but sometimes that can happen. But for this problem, it doesn't really matter. The only term or only number that I'm focused on is this negative 3. That's my slope. So I don't care what the y-intercept is. Okay, and then my other line, I had 12x plus 4y equals 1. Remember, that's in standard form. So I'm going to subtract the x to the other side, move him over to the other side. So 4y equals, I'm going to write the negative 12x first and then the plus 1. I'd make it a plus 1 because the 1 is positive. Then I divide everything by 4. Every single term gets divided by 4. So y equals negative 3x plus 1/4. And again, I get another fraction from my intercept. That doesn't matter. The only number I'm looking at right here is the number that's in front of the x. And there my slope is negative 3. And now you can see that my slope for my first equation and my second equation were exactly the same. So yes, these lines are going to be parallel. And the symbol we use for parallel is 2 little backslashes. next to each other. That's a little symbol for parallel lines. So if you want to use that symbol, feel free. So again, the reason we're talking about parallel lines is because when you have equations that are in slope-intercept form, it's very easy to identify the slopes and compare them. So here are your examples for tonight. And in class, we're going to look at example 46 and 48 and just go through them together and talk through them before you actually do them in your homework. So if you have any questions, come on in and see me before school.